Dear students, today's class let us discuss about the alcohols, phenols and ethers chapter. In that, let us discuss chemical properties of alcohols and phenols. So, here both alcohols and phenols reacts as nucleophile and also as well as electrophile. So, on the basis of the nucleophile and electrophile consideration, we may consider while cleavage of a bonds OH bond or CO bond. We can discuss two types of cleavage of bonds can be takes place in alcohols and phenols. So, whenever the bond between OH cleavage when alcohols acts as nucleophile. So already I told you that both alcohols and phenols reacts as nucleophile and sometimes electrophile. But so whenever the bond between OH is cleavages, when alcohol acts as nucleophile. So here I have taken one example. So here one example for the cleavage of OH bond. At that time, alcohol is acts as what? Alcohol is acts as when OH bond is going to be cleavage. At that time, alcohol is acts as nucleophile. So this is what here. If there is a presence of positive charge carbocation, this is carbocation. This is indicated as electrophile. So this is what? This is electrophile. So whereas in case of alcohol, this is having two lower pair of electrons. So this is considered as nucleophile. Nucleophile. So as I told you already, when there is a cleavage of OH bond, at that time this alcohol is acts as nucleophile. So here let us see how does the OH bond is going to be cleavage. So when alcohols are reacts with electrophile, so at that time there is going to be obtain this product, that is ROH. This electrophile will directly substitute to this nucleophilic alcohol group of oxygen atom. So it leads to the formation of here carbocation. So to satisfy this oxygen valency, so ultimately the hydrogen atom of this alcohol carrying oxygen atom carrying hydrogen atom, that hydrogen will eliminate. So ultimately this bond is going to be cleavage, then such lone pair of electrons will get back to its oxygen atom. So what happens now? Oxygen again it will gain 2 electrons, then it becomes satisfied. Next what happens? Carbon. Next is this hydrogen will eliminated as H plus ion. So that H plus is the release of H plus. We can say that here alcohols are acts as acids. Alcohols are acts as acidic in nature. So because of that, here the H plus ion is going to be releases. So as you know that the proton release substances are called as acids. So that's why according to Brownstein acid base theory, we can say that the substance which is tendency to donate proton, such type of substances are called as Brownstein acids. So here alcohol is acts as acid. So here because of release of H plus ion. So now we confirm that here what type of bond is cleavage? OH bond is cleavage. See here ROH is there after attacking electrophile. So here is the attack of electrophile. After attacking electrophile, this oxygen atom so bonded with hydrogen, that bond is going to be cleavage and that hydrogen will eliminate. Means that the cleavage of what type of bond? Cleavage of OH bond takes place. At the time, due to cleavage of OH bond, this alcohol is acts as what type of species? It is acts as nucleophilic substituent. So this is acts as electrophile. So similarly, let us take the one more example. This is alcohol, this is phenol. So whenever phenol is nucleophile, if it is an electrophile, there also the cleavage of OH bond takes place. Here due to cleavage of this OH bond, so the release of H plus ion can be seen. So due to cleavage of this OH bond, this phenol is also called as nucleophile. So now we can consider this phenol is nothing but nucleophile. So why? Because here the OH bond is going to be cleavages after substitution of electrophile to this nucleophile. The electron rich species are called as nucleophiles. The electron poor species are called as electrophiles. So this is carbon positive, that is electrophile, that is carbocation is acts as electrophile. Is acts as electrophile. So here, so when this electrophile, if it is substituted to this nucleophilic reagent, so nucleophile, this is electrophile, which are immediately which will react with each other. So after attacking this electrophile to this oxygen of nucleophile, so what happens, that here we are observing, so this carbon atom will attack to this oxygen atom. This hydrogen I have written upon side. For our convenience we can write like that. So this is hydrogen atom, this is carbon atom is directly substituted to this oxygen atom. So what happens, this oxygen will not satisfy its valency. Oxygen valency is 2 bond valency and it has to be remain 2 lone pair of electrons. So due to that instability, so this bond is going to be cleavage and this proton will releases as H plus ion and these bond electrons will shifted over on the oxygen atom and ultimately the oxygen density is going to be increases. So that can be written in terms of, this can be written as aromatic, or again lone pair of electrons will get back on the oxygen atom and the remaining is carbon. So rest out is this H plus ion. Remaining is that H plus ion. So this is about the cleavage of OH bond during the reaction with the electrophile. So when the cleavage of OH bond takes place from alcohols or any aromatic phenols, so at that time such type of alcohols and phenols are nothing but nucleophiles. So here the cleavage of OH bond, here also cleavage of OH bond. That's why this is also considered as nucleophile. It acts as nucleophile. So this is electrophile, this is electrophile. So one more condition is there. So if the bond is cleavage OH, then we can consider as nucleophile. If in case the bond between CO cleavages, when alcohols reacts as electrophiles. So see here, what is the difference between these two? When the bond between OH cleavages, at that time the alcohols and phenols are acts as nucleophile, whereas in case of the cleavage of CO bond takes place when the alcohols reacts as electrophiles. So dear students, now let us take one example. So how does this alcohol is acts as electrophile? So let us take one example. So when RCH2OH, so oxygen having 2 lone pair of electrons. Further, it reacts with proton. Proton means acidic proton is H plus. That what happens? This is electrophile, this is nucleophile. Why? Because electron rich in species. That's why this H plus will attack to this oxygen atom of hydroxyl group. Then what happens? We are going to get a protonated alcohol. That is the formation of RCH2O. Already one H is there. This lone pair of electrons which provides to make a bond with another proton. So that leads to the formation of OH bond and remaining is rest of one lone pair of electron. So this is considered as protonated alcohol. So when this protonated alcohol which when reacts with nucleophile, so this is acts as what? This is protonated alcohol. This is acts as electrophile. So that is RCH2OH and H. So this is acts as what? This is protonated alcohol. So what do you mean by protonated alcohol? Alcohol, if it is substituted by one more proton, that is called as protonated alcohol. So this is nothing but here this is electrophile. This is electrophile. So when this electrophile, so what happens? So if the alcohol is acts as electrophile, at that time what type of bond is going to be cleavage? So whenever the alcohol is acts as electrophile, then at that time the cleavage of CO bond takes place. Okay, here where the bond is going to be cleavage, either OH or CO. So if the alcohol is acts as nucleophile, then ultimately the OH bond is going to be cleavage, as we seen in the above two examples. See here this is the acts as nucleophile, so that the OH bond is going to be cleavage. So here we are observing the cleavage of OH bond. Okay, and here this alcohol is acts as electrophile. If it is an electrophile, the cleavage of CO bond will take place. Now, if the electrophile, if it is reacts with nucleophile, that is for example bromide. So this is nucleophile. This is nucleophile. So what happens now when this electrophile is reacts with nucleophile? At that time the CO bond is going to be cleavage. So here ultimately CO bond is here. So this bond is going to be cleavages. And ultimately these lone pair of electrons of this bond electrons will shift over on the oxygen atom. Why? Because oxygen is suffering from one lone pair of electron. That's why as usual it will get so again one lone pair of electron by the cleavage of CO bond, and this carbon atom will get a electrophile. So what happens? This electrophile immediately interacts with this bromide nucleophile. So ultimately what happens? The formation of RCH2 Br plus H2O. Dear students, now you clarified that. So here due to cleavage of OH bond, alcohols are acts as nucleophile. If the CO bond is cleavage takes place in any alcohols or phenols, then ultimately such type of alcohols or phenols are nothing but electrophiles. So this is about the chemical properties of alcohols and phenols. So based on the alcohol, phenols, nucleophile and electrophile substituents, we can classify these chemical properties into two types. The one is the cleavage chemical reaction, which is cleavage on the basis of CO bond, and a chemical reaction which is cleavage based on the OH bond. Let us consider continuation. Dear students, so already I told you that, so based on the cleavage of OH bond and CO bond, the reactions of alcohols and phenols can be broadly classified into two types. So one is reactions involving cleavage of OH bond. So some chemical reactions of alcohols are having the cleavage of OH bond, and some chemical reactions are having the cleavage of CO bond. So here two types of cleavage of bond can be seen. On the basis of that, we can see the reactions of alcohols and phenols in the classified into two types. One is reactions involving cleavage of OH bond, and another one is reactions involving the cleavage of CO bond. So first let us consider the reactions involving the cleavage of OH bond. So first let us discuss about the cleavage of OH bond, the chemical reactions, and next let us go for the reactions involving cleavage of CO bond. So firstly I will consider first one, that is reactions involving cleavage of OH bond. In that let us discuss about the acidity of alcohols and phenols. Here the cleavage of OH bond means here after cleavaging of this O and H bond, the release of H element will take place, that is H plus ion we can say. The release of H plus ion is called acid. The release of H plus ion, H plus is what? Acidic proton. The release of acidic proton is nothing but so acidity. Acidity is goes on increases. So that's why. So these alcohols are acidic in nature. So let us discuss some chemical reactions of acidic nature of alcohols and phenols by cleavage of OH bond. Now, let us consider first chemical reaction, that is reaction with metal. So, here any alcohols and phenols which when reacts with highly reactive metals such as sodium or potassium or aluminium. So, in such a case, so when these alcohols and phenols which when react with sodium, potassium and aluminium of highly reactive metals, such leads to the formation of alkoxides and phenoxide molecules. So further it leads to the formation of dihydrogen gas, and also as well as sometimes these alcohols and phenols can also react with bases. Why? Because due to release of H plus ions, so these alcohols are called as acids. So when these alcohols are acts as acids, when we consider a strong base like any OH which can able to react with each other, that leads to the formation of acid base reactions. So now let us consider a chemical reaction of alcohols react with sodium and aluminium. So as like potassium, sodium is monovalent, potassium is also a monovalent, right? Any one you may consider. First let us consider sodium as like potassium. So I will take only sodium reaction, and similarly we can follow for potassium, and next after that I will go for aluminium. Okay, first let us take the reaction of alcohol. So when the alcohol generally ROH. This is an alcohol. So example for the reaction of alcohols with metals. So when this alcohol, if it is reacts with sodium, if it is reacts with sodium, that leads to the formation of, what is the formation of product? So alcohol oxide may be formed. I told you that. So due to cleavage of OH bond. So when this OH bond is going to be cleavages, so then this H plus ion is going to be releases as an acidic product. So ultimately this sodium will attract to this oxygen atom. This is R O Na plus of H. Of moles of hydrogen gas is eliminated. The release of H takes place. So, for example, if you consider two molecules of alcohol reacts with two molecules of sodium atom or metal, that leads to the formation of two molecules of alkoxide, sodium alkoxide. Two molecules of sodium alkoxide. This is dihydrogenase. It exists as gas. So, further, if you consider the reaction of alcohol with aluminium, let us take the alcohol, that is tertiary butyl alcohol, we may consider. So, tertiary butyl alcohol, as you know that, how to write the tertiary butyl alcohol. So, this is COH, this is CH3, CH3. This is what? This is tertiary, as we write T, tertiary, or we write tertiary. So 3 superscript 0. This is called tertiary, or we write T, tertiary butyl alcohol. So when this tertiary butyl alcohol, the 6 molecules of tertiary butyl alcohol, which when reacts with aluminium, 2 molecules of aluminium, that leads to the formation of alkoxide ion. First, the cleavage of OH bond takes place. So this is a reaction with the cleavage of OH bond we are discussing. So in all the reactions, the cleavage of OH bond only takes place. Here also the cleavage of OH bond takes place. Here 6 molecules of hydrogen will liberates. So when this aluminium metal, reactive metal, when it contacts with tertiary butyl alcohol, that is the formation of, so here alkoxide, tertiary butyl alkoxide is going to be obtained. Tertiary butyl alkoxide is going to be obtained. So here Al. So 2 aluminiums are there, 2 into 1, 2 aluminium, and 3 to the 6 alkoxide, 6 alkoxides are there, and plus release of what? Release of 3 H2 gas. So this is 3 molecules of hydrogen gas is going to be releases. So that here we can consider tertiary butyl alcohol which will react with aluminium, the release of H plus takes place. So the formation of alkoxide means that what here also alcohols are all acts as what? Alcohols are all acts as acidic in nature. So that we may consider alcohols are acts as acids when there is a cleavage of OH bond takes place in a molecule. So similarly, dear students, let us take some examples for phenols. So let us take example for phenols. I will consider example for phenols. So here example for phenols. First one is, so when phenol reacts with, it is aromatic benzene ring having one OH group, that is called as phenol. So this is called as phenol. When this phenol molecule, if it is reacts with sodium element, that leads to the formation of sodium phenoxide. So this is the molecule called as sodium phenoxide. Oxygen is having 2 lone pair of electrons. Here also oxygen is having 2 lone pair of electrons. When this sodium interact with this phenol molecule, here also the cleavage of OH bond takes place. So that H plus will form in the hydrogen gas. So this is about the reaction of highly reactive metal with phenol. So whenever if you consider, so phenol is acidic or basic. So acid or base. So phenol is acts as acidic in nature. Why? Because here the release of H+ion. So due to release of H+ion, it acts as acid. So now let us consider. So when phenol reacts with alkali, that is sodium hydroxide. So sodium hydroxide is a base. So this is an acts as acid. Why? Because due to cleavage of OH1 and releases H+ion. So such type of substances are called as acids. So now what happens? Due to cleavage of this OH bond, the formation of phenoxide, sodium phenoxide is going to be formed. Sodium phenoxide ONA plus what happens here? Na, this hydrogen and this hydroxyl group combinedly to give an water molecule. Yes, students, this is called sodium phenoxide. This is called as sodium phenoxide. Sodium phenoxide molecule. This is also sodium phenoxide. This is also sodium phenoxide molecule with formation of one molecule of water. So this is about the cleavage of OH bond by the reaction of highly reactive metals such as sodium, potassium and aluminium with different kinds of alcohols and also as well as phenols. So now let us consider on the basis of these chemical reactions we can conclude that these alcohols and phenols are acts as acids. Why? Because all the alcohols and phenols, by the cleavage of OH bond, the releasing of H+ion takes place. So that we can consider these alcohols and phenols are acts as considered as acids. We can say here also this is acid, this is base. So these type of reactions are called as what? Acid-base reactions. So ultimately this is acts as acid, this is acts as base. So due to release of H+ion it acts as acid. So ultimately this is base. So we can consider sodium phenoxide as a molecule is going to be formed. Dear students, so we have discussed all the alcohols and phenols with cleavage of OH bond when they react with highly reactive metals like sodium, potassium and aluminium. So those reactions, the above all the reactions, proves that alcohols and phenols are acidic in nature. So due to cleavage of OH bond, the release of H+ion takes place. That's why all the alcohols and phenols are acts as acidic in nature. So according to Brownstein acid base theory, the substances which tendency to donate a proton, such type of substances are called as Brownstein acids. So all the alcohols are acts as Brownstein acids. So now let us consider one example for the Brownstein acid and base. So when base which when reacts with alcohol, this is alcohol ROH molecule, I have written in reverse form. This is base, this is alcohol is acts as acid. So all the alcohols and phenols are acts as acids. So this is called as base. So when acid base reacts, this base it tendency to accept one proton by cleavage of OH bond. This hydrogen will substitute to this B. So this becomes BH plus the remaining is alkoxide. This lower pair of electrons will shift over again on oxygen atom itself. So this becomes as conjugated acid. This becomes as conjugated acid. This becomes as conjugated base. So here we confirm that all the alcohols reacts with base which leads to the formation of conjugated acid, conjugated base. So now we can confirm that alcohol is acts as acid. So due to release of H+ion. So next let us consider whenever the alkyl group is goes on increases. So for example, if we consider, so or else you can take CH3OH. This is methanol, and this is CH3CH2OH, and CH3 twice COH, and CH3 thrice COH. So among all these alcohols, which is more acidic in nature, which is less acidic in nature? As the number of alkyl groups goes on increases, the acidity of alcohols is goes on decreases due to decreasing the polarity of OH bond. So here CH3OH is an alcohol. This is the cleavage of OH bond takes place very easily, so it acts as more acidic in nature. So next, when we consider this molecule, so this carbon atom is having one alkyl group. This is alkyl group are the electron releasing groups. As the electron releasing groups are goes on increases to the carbon oxygen hydrogen carrying carbon atom, then ultimately the polarity of OH group is goes on decreases. Though that's why the release of H plus ion becomes very difficult, so that the acidity goes on decreases. So when we consider this carbon and OH, here this carbon atom is having 1, 2, 3 alkyl groups, so it is very difficult to release the H plus ion. So when we consider the alcohol group, if it is considering 2 are the alkyl group, one is hydrogen and one more is COH. Here 3 valencies are satisfied by hydrogen, one is satisfied by alkyl group. So here what happening? Here the number of alkyl groups are more. Here number of alkyl groups are less. Here very less. So as we goes on, the alkyl groups are goes on decreases. So here only hydrogen atoms. Here what happens? The acidic nature, this is very less, very lesser in acidic. Why? Because the polarity of oxygen and hydrogen is very less. So the due to presence of all the alkyl groups are electron releasing groups. As electron are going to be released towards the oxygen, so oxygen density is goes on increases. As the oxygen density increases, it is very tendency to attract towards itself the hydrogen atom towards the oxygen. So there is no chance to release of H plus in the alcohols. Why? Because due to more number of alkyl groups. Here only 2 alkyl groups are there. Here 2 are the electron releasing groups. So this is little bit more acidic than this molecule. So this is very less than this. Why? Because here 2 alkyl groups are there. 2 are the electron releasing group. The electron density more on this oxygen atom, so unable to release the H plus ion. So here only alkyl group, one is there, electron releasing group. So it is little tendency to donate the electrons towards the oxygen. So this is little bit more acidic than that of this molecule. So this is still lesser than that of that molecule. Why? Because here there is no alkyl group, there is no electron releasing group. So that's why this is little bit more acidic in nature when we compare to this molecule. We can say that. Okay, dear students. So one more important thing is alcohols are lesser acidic in nature than that of water molecule. Okay, let us consider. So as you know that here tertiary alcohols we can consider. Tertiary alcohols are lesser acidic than secondary alcohol. Secondary alcohols are lesser acidic than primary alcohols. So this is primary alcohol is more acidic in nature, or else primary alcohols are higher acidic in nature than secondary alcohols than tertiary alcohols. We may write like this: as the number of alkyl groups goes on increases, which influence the electron releasing groups on the oxygen atom, the electron density is going to be increases. Ultimately, there is no release of H plus ion. So what happens here means the polarity is goes on decreases. As the polarity is goes on decreases, there is no chance of release of H plus or hydrogen from the oxygen atom. That's why the alcohol's acidity is goes on decreases when the number of alkyl groups is goes on increases. That is the reason. Remember, it may ask for 1 mark at the point of examination. Right. So now I will consider alcohols are less acidic than water. Less acidic than water molecule. So how? And why? As you know that alcohols are acidic in nature, but when we compare to the water molecule, alcohols are lesser in acidic. So water is more acidic. So if there is a example, so when alcoxy group reacts with water molecule, here what happens, this is a water molecule, this is tendency to rapidly provides one proton to this alcohol molecule. So alkoxy molecule, that is the formation of OH, and this forms OH. So this is the molecule, this is excess water, this is excess base now, this is excess water, this is acid now. Why? Because this is a proton donor. Already I told you that the substance which is tendency to donate the proton, such type of substances are called as Brownstein theory ಏನಂತೀವಿ acid ಅಂತ ಹೇಳ್ತೀವಿ. According to Brownstein it is an acid, according to Brownstein it is an base. Why? Because the tendency to accept the proton, that's what is base. This tendency to donate the proton, that's what is called as acid. This is called as conjugated, acid now it is. This is conjugated base now. It is tendency to accept now, it is tendency to release now. So conjugated means there is only difference is proton, there is only difference is proton. Here one proton is more, here one proton is less, here one proton is more, here one proton is less. So this is tendency to accept the proton now, that's why it is base, which is going to accept, that's why base. It is tendency to release, that's why it is acid. Okay, so this is the clarification. So alcohols are less acidic than water. Why? Because here acid is having so one proton, it can able to donate to the alkoxide molecule. Here alkoxide is considered as base. Why? Because due to presence of unshared lone pair of electron on the oxygen atom, it is considered as basic in nature. If there is a presence of unshared lone pair of electrons are present on the oxygen atom, then it is considered as base. When this base reacts with water, it is acts as water is acts as acid. That's why here alcohol is lesser acidic than water. This is more acidic. Why? Because it is going to be provide the proton to this alcohol molecule. That's why this forms conjugated acid, that is alcohol. So from water, conjugated acid is going to be formed. That's why water is more acidic than that of alcohols. Yes, students, this is all about the cleavage of OH bond, and whenever the cleavage of OH bond takes place, ultimately we can say that such type of substances are called as alcohols or either phenols, those are called as acids due to cleavage of OH bond when they react with highly reactive metals. And ultimately we can consider acidity of phenols. Let us consider the acidity of phenols.